Hi, welcome back. Today we will try Coral TPU. So it's finally arrived. Okay, let's place it here. And I also got Pineberry Pie bottom hat. I got bottom hat because obviously I've got the camera at the top, so I don't want to put it on top, but I don't think it matters. So I got this version because it's gonna fit here. You can obviously get the top hat with the smaller version. It's essentially the same thing. So the cable came in plugged, which is good, so I don't make mistake. So I'll try to put that in together and see if it works. Sorry, keep getting out of the frame. I assume I need to screw that in. Oh, maybe this would help. Okay, so I don't even know whether this is correct, but I'll try. And I'm assuming it goes like this, so it turns out I have a special ability to plug things the wrong way first time, so it should be plugged like this, and after a bit of setting up I managed to run the example that comes with the Coral TPU. So to set up the Coral TPU, I'm following this page. This page is quite easy to follow, just Raspberry Pi Coral page. So I will just briefly go through the files that I need to change. I mean, it's good to read all of it, but if you can't be bothered, then you might as well follow this. So the first thing we need to change is the boot file. I mean, obviously I already done all the update, so it's already there. So those 3 lines need to be added, and then he's explaining a bit more about it. But basically for this file, just those 3 lines. I'm not gonna edit it. And then the next thing is need to edit boot command line. So basically that argument was added. and then need to change something called device tree. So there's another page talking about how to do this. So basically you need to make a copy of this, and decompile that setting, and added a very specific line, which is under PCIe. So it's this line. Obviously it was different value, 02, but now since I already edited, it has the up-to-date value, and then you just need to recompile and then put it back, then you're good to go. And after that, what we need to do is try to test this, and then as the document talking about this, that using the Docker image is the easiest way to do it. I will talk about for Python 3.11 because I wanted to make it work for Python 3.11 because of the PyCamera 2 module, but for now we want to make sure that this TPU is working, so let's just stick to the Docker. So if we go to this page, before actually running the Docker, we need to make sure this PCIe device is working, and then we need to follow the official guide of Coral TPU. So we need to go here, we need to go to install PCIe driver for Linux. So I mean basically we need to follow this instruction. If for the very first time when I run this command, it was not printing anything because nothing was installed, but obviously now I have something there. But if it's your first time, it will print nothing. Then you just follow along, run this command, run this command, and run this command, and reboot. And after the reboot, if everything was done correctly and then devices plugged in correctly, then we should be able to see the device, the Coral TPU device. So I mean I already checked it, but let's double check. So yes, I can see the device. So now we are ready to run our Docker image. So let's go back to the Docker. So I've already installed the Docker, so I'm not gonna copy and paste this line, but it's really easy to install. Just copy and paste, and then you need to build a Docker image. You only need to do it once. So which I already did here. Basically made the Docker file, which is just copy and paste of this and run build, which I already did, so I don't need to do it again. and then when everything goes well, we should be able to run the Docker image. So I'll paste it and run it, and now I'm in a Docker container. So the example command for that Docker container is this. It's quite long, so copy it and paste. So it ran the example script and it executed correctly because it's printing out the expected value. I think it's listed somewhere. Yes, so basically got the same result. So now I can verify a listed device is running, and there's no problem with the device. So next step will be trying to run Coral TPU in Python 3.11, not a Docker container, because in 3.9 I don't think I can get the PyCamera 2 module because it's only available in Python 3.11. So I'll talk about that next. So my next challenge was to make PyCoral work with PyCamera, because PyCamera 2 only works in Python 3.11 and PyCoral only works in 3.9, at least in the official release. So this is the PyCoral official release, and there is no, there's a Python 10, a 3.10, but no 11. So it's not gonna work. So I spent a lot of time trying to make this work, and I ended up doing a little bit of hack, but I'm okay with it, and then I will explain why. So the very first thing I decide to do is to find whether somebody else built PyCoral for Python 3.11, and this person did. This wonderful individual compiled several different versions for several different Python version, and basically this was exactly what I needed. So I thought, problem solved. Not quite. So when I actually tried to pip install this, it doesn't like it because it cannot find TF-Lite runtime of specific version 2.13, and there is no such version. So first I was trying to see how easy that is to compile this myself. It turned out not very easy. So the next thing I tried was I tried to compile PyCoral itself by cloning the PyCoral, the official PyCoral, and then compile to 3.11, which turned out to be challenging as well. After hitting several issues and several hours of screaming, I decided to give up. So then after that I decide, because I don't care which version, I just want PyCamera 2 and PyCoral to work together. And since the official version has for 3.10, Python 3.10, or also this one has a 3.10. So I thought maybe I can compile the libcamera, which is a dependency of PyCamera 2, which stops me from running it in different Python version. So I also tried to compile libcamera in Python 10, which I could compile it with the Python bindings, but it didn't work. It gave an error, very vague error, and then I googled it, and then I saw somebody else having the same problem, and it wasn't working. So at the end I thought, oh well, maybe I should just stick to this version, but ignore these dependencies. I mean, which is gonna be a hack, and then there's a very good chance that it will blow up, but I thought there's a chance that it wouldn't. So I basically installed the 3.11 version without the dependency. So I force install it even though there's no TF Lite 3.13, and then I just installed the 3.14, which is available in Raspberry Pi. I mean, in this OS with the Python version. So it installed without error. So I thought it could work. Okay. So the very first thing to do is to verify it actually runs. So, oh, not this guy. So since I already checked out the PyCoral source code, it comes with an example. So I decide to, so basically this is Python 3.11, and then can't type. I have a PyCoral installed here as well. I mean, all the instructions are in the README, so you don't need to worry about it. But then I thought maybe I can run the example. Oh, where did it go? Ah, there you go. So this is the example, comes with the PyCoral repo. So if I run this, it did run, and it was saying the first inference of TPU is slow because it needs to load things into the memory, so it's slower, and then the rest of them are fast, and it ran. So at least it didn't blow up, and it could load the TF Lite file, and then it could run it. So I was happy. So the next thing is to see what I can run the YOLO model with this TPU. So I prepared a script. So I made a little change so it defaults to a model that is I already included in the GitHub. But the main difference is basically I had to do a little bit of extra pre-processing and post-processing before feeding it to the model, because due to the quantization, but I found the code from the example of PyCoral, so I mean, without this it still works, but it doesn't work properly. So that is all done, and I thought, well, let's run it. So I exported the model to the HTPU format, which you can. I tried to do the export in Raspberry Pi, but basically it was getting a lot of errors. So I don't know why, but I just decided to just do it in my Linux machine. So the command was Yolov8 export. Oops, I'll bring it up. Yolov export model, the Yolov8 and model to HTPU, and for the, I just did it in my Linux machine and it exported without too much issues. So I thought, oh, that's good. I can copy the files over and then I can run it. So this is the file. I renamed it to 640 TPU because, well, this is the original resolution, and I was thinking what's gonna happen, and the answer is come on, it crashes. So I thought, I guess it was too big, so I exported low resolution version 320 by 320 to the HTPU version, and it crashes. So at that point I thought, oh well, I must be doing something horribly wrong. This is before that I actually tried like even low resolution 224, and it also crashed, and then I thought I was doing something wrong. So I was googling, and then I found this page. Basically somebody else already tried it, and then the highest resolution that works is 192 by 192. So basically this TPU is so tiny that is the highest resolution you can afford to run it. So for the sake of actually running it, 192 version, and it runs at 30 frames per second. Let me wave. It's a remote desktop, so it's a bit choppy, but it does run at 30 frames per second. But it's at really low resolution, and actually at this resolution, even 320 by 320, the CPU version runs at real time 30 frames per second. So it turns out for your low model, at least, TPU, Coral TPU is not so useful, which is very disappointing. Maybe I was expecting a little bit too much for a tiny TPU that costs only 25 US or something like that, but I thought at least it could handle slightly higher resolution. Maybe I should have done much more googling before buying it, but I thought when I actually heard about PCIe and then capability to actually connect to TPU, Coral TPU, I just ordered it without too much research. So, well, at least I think I learned a lot. And that was fun. Maybe this TPU is useful for other projects rather than Yolov8, because I think 192 by 192 is way too low resolution. But yeah, that was the end of my experiment. Hope you guys enjoyed it, and hopefully you guys don't need to struggle as much as I did and then just get straight into this position if you willing to experiment more. But like, keep that in mind that for this specific TPU, you can only run very low resolution. I do notice there is another TPU which is a 2 TPU together, which is a slightly more expensive. I didn't order it because I wanted to see the basic version first. So that's supposed to be twice as, it has a 2 units of it, so basically it should be handled twice as more than this, but twice as more for 192 version because of its images 4 times. So it's not even that. I don't think it will cover higher resolution. Maybe can do 256, I don't know, but definitely it will not cut for 640 by 640 for sure, because yeah. So thank you for watching.